Welcome to the joy of coding.
Hello, and welcome to episode 73 of The Joy of Coding. My name's Mike Conley. It's classic hacking on Firefox that's going on today. Full disclosure, I really did not prepare a whole lot. That's not unusual for these sorts of things, but more so this time. I really only have a bare idea of what we're going to do. I think it's a lot of just thinking on my feet. So hopefully it's useful, it's entertaining, it's educational, it's interesting. So we'll see. Let's get started. So first of all, I'm just making sure you can you can hear my stuff. And I'm recording and my mic's working. That's all good. If you are in the habit of communicating via text, you can always join us in the IRC chat room. There are instructions that I will point to you right now on how to do that. So this is the agenda. I say this every week, and I say that every week, but the agenda is super useful for you because it has a bunch of links that you might find useful. So getting to this agenda should be pretty straightforward. If you're watching this on Air Mozilla, if you scroll down, there's an additional links section. I just added a link to this agenda there just a couple minutes ago. So if you click on it, you should see this document. And as I update this document, and as it synchronizes, it should update, although you might need to reload the page. I'm not entirely sure. I got a sort of an idea of what I want to work on today. Only kind of. I threw some notes down like literally about a minute or two ago. Literally? For realsies? I did only a few minutes ago throw down some bugs to work on. There's plenty of work to do. It's just what work would you find interesting? That's what I was trying to figure out. So if you're interested in joining us in IRC, you can always click on this link in the agenda. If you click on this link, it will take you to the Mibit IRC client, where if you were to choose a nick, in this case, like your nickname, in this case it's randomly generated one, but I'm going to create a new one. I'll call myself Giraffe 105, and I click go. In a second, it's going to sort of sort itself out, and bam, I'm in there, and I can talk. I can say like, hello, M. Conley. And I'll see that. In fact, I just got a notification about it. In fact, that's a good reminder that I'm going to turn off notifications so that people don't spam and create a bunch of ridiculous nonsense in the stream. But I will be able to see it off screen. So if you need to communicate with me, that's the way to do it. So I'm going to leave that chat room and let's move on. So that's how you get into the IRC chat. What am I going to do today? I'm looking at this bug 1241459, which is all about making it possible when we have let's say we have two content processes. Like E10S, which thank goodness is currently shipping to, I believe, about half of our release population right now, or it should be. Half of our release population is roughly eligible right now, somewhere around half, maybe a little under half. And so we ship with a single content process, and the content process is the stuff it's the program that's rendering the actual web content, whereas the main process is what renders the outer browser user interface, and these two processes communicate to one another. And this process separation is what electrolysis, or E10S, was all about, is having these two separate programs. So that if, for example, let's say a web page does something a little screwy and causes a crash, it causes this part to crash, the tab to crash, but the whole browser will stay up, and we can handle the crash of the content process. And that's good. I mean, let me show you an example of us crashing, and you'll see what the experience is like. Maybe you've seen it before. I've got an add-on that will simulate a crash. So let's say we start up the browser. I'm going to close this toolbar. Why am I at W3 Schools? Good question. I don't know what I was here for. I think I was just looking for some kind of cheap way of testing select pop-ups or something. Anyways, if I were to go to my add-on, and there's this button that says Crash Content Process, and if I click on that, then it will send an instruction that causes the content process to crash. And first it turns white, and then we see this. Now that turning white's not an amazing experience. Um, It'd be best if we did that sooner, but this part is what we get. This tab has crashed, and this is useful because it tells the user, hey, something's gone horribly wrong. What do you want to do about it? And most of the time, you probably want to restore this tab, and then you can go about your business. Now, if you have tabs in the background whenever you crash, like for example, suppose I'm at my blog, what we do, and I think I may have actually worked on this particular feature whenever we were live streaming, but if we crash and the background tab is also connected to the same content process, if it crashes, then this doesn't go to this page. If I click on it, what happens is it will just automatically reload. So we see this one tab crashed page, and the rest of the tabs reload upon click. That's what we've got right now. That's the behavior we've got. But whenever we have multiple content processes, now we have a third case. We always had this third case because we have non-remote pages. So for example, About New tab is a non-remote page currently. So my remote new page is blank, but it's running in the main process. And so it's possible for the background tab here, this one running in the content process, to crash. But what do we do in that case? Do we want to communicate to the user, or do we want to just reload it whenever the user clicks on it? What do we do? So the answer is, or at least what our UX team wants to do, is for all of the tabs that crashed in the background, like keep behaving the same way if the foreground tab, the one that's selected, is one of the group that crashes. If that's the case, fine. Just do the same thing we've been doing. However, if it's not, if we're in this case where we're looking at a tab that's either in the parent process or in a completely separate process, and some background tabs crash, then of those background tabs, the first one I click should show me About tab crash, that tab crash warning, and the rest should be restore on click. So how do we make that work? Well, that's what I'm trying to figure out. That's where you've caught me. That's where I am right now in my head. So check out the notes. I've linked to the notes in the agenda. I'm trying to mull over how I want to do this in my head. And that's where we're going to... just reading some chat stuff to make sure it's not something that I need to respond to. Okay. How do we want to do this? And now that's what I'm going to work on. I'm going to kind of work on this stuff out loud. How do we deal with this? And I wish I'd brought a glass of water. I might come to the point where I have to run out and grab one, but we'll see. So let's dive in. Okay, where was I? Where was I when thinking about this problem? So we've already got half the problem solved. We have the case where the selected tab crashes. We have that solved. The other half is the tricky part, and we have to make that other half of the solution work with the first half so that they still behave, like the first case still behaves the same. So I've got this notion of a trap, some kind of trap mechanism where if only background tabs have crashed, so tabs that where none of them have been displayed to the user across multiple windows, if none of them were the selected tab, then we create some kind of trap where upon clicking one of the trapped tabs, we show the About tab crash page in the one that was clicked, and then we remove the trap. And well, it gets a little more, it's a little more nuanced than that, or there's another step. When we crash background tabs, we revive all of them automatically, but we also have the second step of the trap. And the trap, which I haven't really defined yet how it works or where it's going to live or what its responsibilities are exactly. But when we are in the trap state, for the tabs that are trapped, when the user clicks on any one of them, we remove the trap for the rest of the tabs, and then we send that tab that had been restored, we send it to About tab crashed. Does that work? Yeah, but there are some considerations. One thing I want to remember is that when the user visits about tab crashed, we definitely don't want that to show up in session history. And I don't think it will actually, because it's one of those error pages. It's like about net error, where the URL will still appear to be the same in the URL bar as the page you were on whenever you crashed. But internally, we're at about tab crashed. So I don't think we will be saving any state there. Let's see. But we do have this guard in place. I know that whenever, like, in Session Store, whenever we crash, we go on browser crash. We call this method on browser crashed. That adds the crash browser's permanent key to this internal set. And then we resolve all promises on it. So we've added this browser to the crash browser set, and that means that if any updates come up from that browser, we ignore any updates from it. We'll ignore any updates that come up from a crashed browser, because we don't want to hear about it whenever the user is working with the about tab crashed. And whenever we hear a message of crash tab revived, that's when the user either moved away from, when the user moved away from about tab crashed, that's when we remove the browser from the crash browser's weak map or weak set. Okay. And then we'll start listening to updates from it again. Okay. So we're kind of flip-flopping a bit. Kind of flip-flopping a little. We want to have the background tabs, after having crashed, immediately restored, so that to add-ons, they still appear to be they still have accessible and manipulatable, is that a word? Manipulatable session history, etc. But once the first one is clicked, we need to crash it again and show about tab crashed. We need to, okay. What am I thinking of? What I should probably say it out loud. Do we even need, like, when a tab crashes, we put it into the unrestored background state if it's a background tab. Do we ever want or receive messages from such tabs? Not really, because the content doesn't do anything. I don't think so. I don't think we do. However, suppose we have one of these unrestored background tabs. What's the best way of putting it into the about tab crash state? So that's if the user clicks on it, one of the trap tabs. I'm just trying to figure out if it's even possible to go from an unrestored background tab to an about tab crashed page. That might be a thing I can test, actually. Um, um, there's this SS browser state thing. Tab needs restore. What is it? Tab SS restore state per Zool browser that maybe we can add to. Example, and it's not tab state restoring, but like tab state will restore tab state restore if scene crash. Restore if saw about tab crashed. Saw about tab crashed. Suppose for a second that when all of the browsers crash, all of the background browsers crash, or not all, that when some of the background browsers crash, so what do we do then? Inside here we update the remote disk to false, and then we revive the crash tab. And reviving the crash tab means getting rid of the entry in crashed browsers, and then we remove the crashed attribute if one exists on the browser. We put the browser at about blank in case the user is restoring tabs on demand. That way, the user won't see a flash to the About Tab Crash page after selecting the revived tab. We do this browser load URI. Okay, about blank. Then we collect the tab state on it. And then we restore the tab, but force on demand, but we make sure it's going to be on demand. When we say restore tab, force on demand, this is where I think we set that value. Or somewhere, let's see. SS restore state equals. We'll do that in restore tab, yeah. We say the tab needs restore. Force on demand. Yeah, it should be force on demand after crash. And then if force on demand after crash, then make the restore state tab state needs restore if saw about tab crashed. And then in on tab select, if we saw, we could have it query tab crash handler, if tab state needs restore, tab state restore if saw about tab crashed. Needs restore, will restore. When's tab state will restore used? That's after navigate and restore. Tab SS restore state. Is it ever tab reset local tab restoring state? Need to reset restoring tabs. Tab if it needs restore. Normally done in restore tab content, but that isn't being called for this tab. Needs restore. What is this? What is this? Previous. We flush the browser. What do? We get rid of the browser restore state. It's not in any kind of, okay, we get rid of it. Because restore tab expects us to not have one. That's useful. Must reset the tab before calling restore tab. So reset local tab restoring state. When's that called? That's called when the browser crashes. And on browser crashed, does it set a restore state? What am I trying to do here? I know this is all kind of, I don't know if I'm speaking aloud enough. This is all kind of hairy. I'm just trying to get my states right. There's all this state. I don't even like this name, but suppose for a second that when some of the background browsers crash, or when any browser crashes, we set the, after resetting the we reset the local tab restoring state. Then restoring state. We set a new restoring state. Tab state restore if saw about tab crashed, or a better name if we can think of one. Then when a tab is selected, if the if the tab has tab state restore if saw about tab crashed in SS restore state in on tab select, ask tab crash handler if we're still waiting to show about tab crashed to the user. If tab crash handler says I already showed the user about tab crashed for this particular crash, then story I moved to the right bucket on tab select. I already showed the user about tab crash for this particular crash, then restore the tab content. Otherwise, do nothing, as tab crash handler is going to show the user about tab crashed, I think. How will, okay, so that might work. How will tab content handler or tab crash handler know if a browser belongs to a crash for which the user has not yet seen about tab crashed for? Well, that's a complicated sentence. Note that a browser can be involved in multiple crashes. It's the frame loader that's unique. From crash to crash. That's an observation. So like if I crash, well, gbrowser selected browser.frameloader has a child ID. If I set that frameloader to F, let F equal that, and then I crash this, whoops, no, that's not what I wanted to do. I want to be in the other browser, this one. So let F equal gbrowser selected browser.frameloader. F.child ID, number 3. Now, if this frame loader crashes, crash content process. Then the frame loader that gets loaded in this browser will not be the same. So gbrowser selected browser.frameloader.child ID should be 0, and so the frame loader is not equal to F. That's true. Now, if I look at F, frame loader owner, F, do I get a Doc shell, no. What, can I get like the owner? Owner element is null. It has no owner. There's no way to associate that, I think, back to the owner element. This is now a dead frame loader. F equals null. So now we can garbage collect that. So that's no good. The frame loader is not helpful because it doesn't give us a mapping back to the browser. You almost need to remember what was the last crash that this browser was involved in. Like, what was the... You almost need a weak map where the keys are the browsers and the values are the child ID of the crash, of the last crash. That way, if a browser crashes again, it will overwrite the old child ID. And if the browser goes away, well, we don't. It's a weak map, so we don't hold a reference to it. Okay, that's a structure maybe we can work with. Except that I can't go from a frame loader to a Zool browser after the crash has occurred if we go ahead and swap remoteness on the browser. Okay. So this is still the question. How will tab crash handler know if a browser belongs to a crash for which the user is not seen about tab crashed for? Okay. We see the event. Let's say there is a notification that's fired. There's also an event that's fired. There's the oop, frame loader crashed. Frame loader crashed. Notification. Map. In weak map, set the key to the browser. Permanent key. And the value to set the key to the browser permanent key and the value to child ID. At the same time, create a map of child ID to weak references to frame loaders, to weak references to Zool browsers. So we've got, this makes it easy for us to associate browsers to child IDs and child IDs to all browsers. This is a one-to-many relationship. Is there a better way of doing that? Yeah, have each browser store the child ID, which they already do. The frame loader knows about the child ID, except that it gets rid of that information. Also, it means that in order to get at all of the browsers, you need to scan all of the browsers, which might not be too bad. I mean, they're maximum, let's say Firefox is stable with 1,000 browsers. Browser tabs, maybe more, 1,500. Even then, you're really pushing it. 1,500 browser tabs. It's one-to-many relationship. Maybe I'm prematurely optimizing. Let's not think about this structure then. We see the OOP frame loader crash notification. We set the key to the browser permanent key and the value to child ID. We also hold hold a list of child IDs for which we still want to show about tab crashed for. Maybe have this maybe to avoid having this grow too large. Well, I can't see that growing too large. Avoid having this grow indefinitely. Perhaps make it a fixed sized array that we record over. So we have a list of child IDs for which we want to show about tab crash for. As soon as the frame, was it the browser crashed event? Not browser crash, frame loader event, and then there's the IPC shutdown content. As soon as the IPC content shutdown notification is sent, if it's abnormal, then for all browser windows, check selected browsers to see if any belong to any have the correct matching, have a matching child ID. If so, we're going to show about tab crashed in them. Remove the child ID from the list of child IDs that we're waiting for. Otherwise, keep the child ID in the list, of course. We scan, we have, if we have the child ID, then it's the standard case, it's the base case. So that means whenever we select any of the, when a user selects any tab, we'll query tab crash handler, which will look up the child ID associated with that Zool browser, and then the check to see if that child ID is in the list of ones that is still waiting for about tab crashed. If not in the list for shown about tab crashed, then do the restore. Otherwise, now we need to send this tab to about tab crashed and remove the item from the list. Move the child ID from the list. This is the trap. Okay. Tab crash handler takes tab. And tells session store somehow to ignore it again. Sends the tab to about tab crashed. Somehow to ignore it again. Tell session store to ignore it again. content session store. There is some stuff about tab crashed. Sends the tab to about tab crash. No, I don't think we expose anything in the session store object for. We have revive crash tab, revive all crash tabs. We could have make crashed tab. Consider crash tab. Let's see. We could have another event in here for like if we load about tab crashed. Tell session store to start ignoring us. Tell session store to start ignoring us if we're showing about tab crashed. Is there ever a case, so question, is there ever a case where an unrestored background tab is one that we care to receive updates from? If not, then we can safely then we can actively ignore such messages if the tab is in an unrestored state. And then my problem is simpler. So that's something to ask about. So maybe I'll ask. See if Mike DeBoer remembers. I'll ping him in IRC. Is anybody in here familiar with Session Store? Remember whether or not we need to be able to listen to update events? Content Session Store if the tab is in the unrestored, in the pending unrestored state. Do you remember? Asking T. Talbert. Asking some previous peers of Session Store who have since moved on to other things but are still hanging around. Let's see what they have to say. Let's assume for a second, though, that we need to care. If we need to care about such messages from unrestored pending background tabs, then we need to expose an API that will, we need to either expose an API that will cause session store to ignore crash about tab crash pages, ignore certain tabs, or even better, have content session store send a message as soon as the error page is asked to load. The about tab crashed. And then stop ignoring as soon as about tab crashed is unloaded. Hope that works. Probably we need to add some tests for that. Okay. Let's pretend that that's how it works. So when we load, when the doc shell how do we do it? We tell the doc shell display load error, and display load error is page where the error happens, string where the error happened, the channel related to this error. Display load error is this thing inside doc shell. We're going to look inside the implementation. Display load error, we get all this stuff. Find out if it's a tab crashed or something, bad cert, unwanted URI, content crashed. Then we send us to tab crashed. We assign literal, all this business, the handler, Chrome event handler. We get the crashed page title. And then we what? Display the error as a string or an alert prompt. We load error page. Load error page. We do an internal load. Load error page, load type. Load error page, that's a load type. Flags error page. Load error page. If we look at the load type, load type. And the web progress. So JSON web progress, get interface done when new tills. We're just looking at like some ways maybe that we could deal with this. On location change. On load. We have on location change. If the web progress, if the load type, if the web progress setup JSON, let's set JSON. If the web takes a progress and a request, if the web progress load type has load error page, do we have something like that in content session store? We have like on state change, location, on location change. We have session storage, we have session. What do we have in here? Page style, doc shell capabilities, session history, session history.jsm, where deserialize, we're serializing, deserializing, don't care. Scroll position changes, frame tree, content restore, add observer to the changes to the session history. We'll collect URLs. Add observer, add history listener. Collect. On history new entry. Just wondering if there's a way we can like have content be aware that it loaded about tab crashed. What's doc shell capabilities? Collect capabilities. Oh, interesting. Frame tree. How can we have about tab crashed be ignored? Because that's really all we want. That's why we put them in that about tab crashed page. Let's do an experiment. On browser crashed. We do this thing where we add the browser to the permanent key list. We're gonna get rid of that. We're gonna see if we get updates from about tab crashed. I think we will. I think that's why we added it. We're gonna double check. Build faster. Okay, now that we've crashed, I'm gonna use the browser toolbox and debug session store, debug update, this one. And I guess what I'll do is I'll try and cause a scroll event to occur. Or even better, I'll try and make a form element show up and then modify the form element. Because there should be a crash report form in here that I can mess around with. Report box. We're gonna. Why does it display none? Whoop. There we go. So let's see if we hit this whenever I fill that in. Am I gonna get an update? No update. That's interesting. Like if I start filling some of this in, any update? That's interesting. Why not? Web developer, browser content toolbox. No content browser, of course. It's in here that I should do this. Content session store, form history, form data, handle event. I'm gonna try and change some form data. Boom. But the frame tree doesn't contain it. Frames created at or after the load event. Well, I'll push it anyways. I'm gonna execute this code. I'm gonna what? So why isn't that firing? Content session store. Let's do it again. Form data. I'm gonna put an event handler there, and then I'm gonna, in the message queue, I'm gonna make sure that the message queue does its thing. Send. Right. So I'm gonna call that. Queue push. Oh, form data listener. So I pushed to the message queue. Let's do it again. Huh. Why isn't message queue push being hit? Very interesting. Let's shut all of that down. Let's also modify content session store so that form data will not care if the frame tree contains the frame. This is all exploratory work. We're just trying to remind myself how the session store stuff works. I think ad block is like killing my load performance. So I'm gonna take that out for a sec. Gonna crash. Gonna set a breakpoint where I want breakpoints. In content session handler or content session store, form data, no, in message queue equals, and then push. And then I'm gonna put that form back. Whew. Easy breezy. Don't hide now. Just whoop, submit. Okay, so we have a push, great. And we're gonna set a timeout for send, great. Okay, we have a dock shell, we clear the timeout. It's not a flush. Get the duration. Then we're going to send session store update. So this is going to go up to the parent. Session store JSM, session store update. Okay. If the message isn't targeting the latest frame loader, discard it. Target frame loader. Don't have crash browsers. We update. Okay, so we are going to update. And what we have like the message, the data, which is form data. Send report true. Shoot. I mean, I could have some kind of like listener inside content session store. That way, I mean, if there were messages in flight from the crashed browser, the parent would still have time to absorb them, because I think the showing about tab crashed in the load event would fire later. But that might not be so bad. It means more data is getting saved after the crash. I mean, another thing we could do is just like in the about tab crashed page, we could send a message to session store from here. Or there is a load event. Send async message. Load. About tab crash. Load. Error pages are loaded as load background. New custom event. Like if we could send async message load. So there's this event that fires. We could listen for that event in content session store. We do something similar for reader, content ready. So we need such stars. We know it's for state changes. Handle event. So we could put something here where we make sure that the document URI starts with about tab crash, send a message to the parent and say, okay, now start ignoring me. Okay, this I think will work. I have a plan. Okay, this took a little doing, but I have a plan. We have a thing in content session store.js called event listener. We fire an event from about tab crashed called unsurprisingly about tab crash load. When about tab crash load is fired, we ensure that the document URI matches about tab crashed, and if so, send a message to the parent saying that we need to be ignored now. Or even better, tell the message queue, disable the message queue. Disable the message queue. We could disable the message queue internally. We could also just have the message queue ignore work, so we don't have the state. We could have it ignore push events and have it check to see if we're at about tab crashed. That seems hacky. So event listener. Event and Don't restore the scroll position. Restore the form data and scroll position. Okay. Load. Have event listener have a black list of pages for which it will disable the message queue if we've loaded it. If we see a load afterwards, and it's not in the blacklist, re-enable the message queue. Okay, that maybe solves this problem here. Then we don't need, if we can do that, then we no longer need the crashed browser's weak map or weak set in session store, since updates will not come up from tabs that are at about tab crashed. Okay. So if we get rid of that crashed browser's weak set, then where are we? When a user selects any tab, query tab crash handler, which will look for the child ID associated with that tab browser, and then check to see if that child ID is the list one's still waiting for about tab crashed. So when tab crashed handler sees about tab crash load, find the associated child ID for the browser, if any, and remove that from the list of child IDs we're still waiting for. Okay, this is starting to take shape. This is starting to take shape. So we've gotten, with the, if we get rid of this crash browser's weak set thing, we don't have to worry about having Session Store be told to ignore things. It'll just kind of work automatically as soon as you send a thing to about tab crashed. If not in the list, do the restore. Otherwise, now we need to send this tab to about tab crashed and remove the ID from the list. So like tab crash handler should have like tab crash handler will handle. Will show tab crashed. Will show about tab crashed. Maybe show about tab crashed. take a browser, and if that returns true, then we showed about tab crashed, and we shouldn't do anything more. Otherwise, restore the tab content. Will that work? Maybe show about tab crashed. Will that work? Maybe. Okay, so let's start specking out work. The first thing is remove the crashed browser weak set, and instead have a way for the content session store to stop sending messages. So stop queuing messages if we're at a blacklisted site. That will actually fix the, I think that might fix some other problems as well. Like this handle revive tab, like as soon as we unload, we don't have to send this crash tab revived event anymore, or message anymore. Crash tab revived. Because, and that'd be nice if we can get rid of some of this stuff. So that's the first piece of work. Second is move the responsibility of taking, or when where's the name of the, yeah. Have tab browser no longer have responsibility for reacting to oop browser crashed except to remove attributes. Have tab crash handler pay attention to oop frame loader crashed, which will then stash the browser in a weak map mapping to child IDs and stash the child ID into a set, fixed sized set. I don't imagine like fixed size set. Child ID is going to be like a number, and this could grow. We need to have some reasonable bound, I guess. I mean, it's just a thing that we'd never collect, we'd never clear out. So that's why I say fixed size. It's just a thing we'd never remove from, or we have the potential to never remove from. Even though it's not a whole lot of memory, we probably leak in other places. Then mapping to child IDs and stash the child ID into a fixed size set. Have session store when IPC content shutdown is fired. So not a weak map, but maybe when IPC content shutdown is fired, put every browser that crashed into the background unrestored state. This means somehow knowing all somehow finding all of those browsers. Finding all of those browsers. And then background unrestored state with a special special SS. What is it called? SS restore state. Finding all those browsers. In on tab select, if we see that the tab has have about tab tab content tab crash handler, remove child IDs from. Oh, that means that about tab crash needs to know which child ID we're showing for. Okay, I can probably add that. Have about tab crashed be told which child ID it's being shown for. Oh wait, no, we don't need that because we know. Finding all those browsers. As soon as see on tab select. Also, when IPC content shutdown is fired, scan all selected browsers to see if they're in the matching, if they're one of the ones that crashed. If so, remove the child ID from the list that we're still waiting for and send those browsers to about tab crashed. If we see that tabs have session store, ask tab crash handler if it will handle it, if it is going to send it to about tab crashed. If so, do nothing. Otherwise, restore the tab. There's some coupling there between tab crash handler and session store, but I think it's probably okay. So we've got kind of a general plan now. That took some thinking. Holy smokes, I wrote no code, but I thought a lot and I read code. And I think we kind of have a plan now. This is the work as I see it. And maybe it won't go according to plan, but this is the work. Okay, it is 2:30. That was an episode of mostly me thinking. I hope that was okay. I hope that was okay, and I hope it was educational. You got to see my thinking process as I went through that. Some of it may not have made a whole lot of sense, but that's sometimes what it's like. I want to thank you so much for watching episode 73 of The Joy of Coding. My name is Mike Conley. I'm going to see you next week, and we're hopefully going to be writing some code that week. We'll see. All right, take care. Bye-bye.
The joy of coding.
See ya.